So malloc, memory allocator, is a function which lets you grab a memory space from a heap section. So what this malloc function will do, we will see it here, and we will also implement in the terminal. Uh, so let's see the syntax first. So the syntax of the malloc is something like this. You write a malloc, a function name, and you pass a size or a number integer as an argument in it. Uh, for here, we are passing a size of integer into 5. That means I want a memory space of 5 times that of integer. So it will return me a memory space of 5 times of integer from the heap section. And malloc returns a void type pointer, and to cast it, you can cast it as you want it. Like here, we have casted it in the form of integer. So this is the syntax of it. But how it works here, let's say this is your program which is calling a malloc function, and I had a table here. Let's call it free memory map table. It is not a professional name, just a nickname by my side. So this table does what is that it keeps the memory addresses of the free spaces in this section. Like it can see that hey, this and this memory are free available in your heap. So when I will call malloc, the in our program, the program will look here, the system will look at the table, it will see hey which memory spaces are available, and then it will grab the pointer from here, and now our program will be pointing to that memory block. This means that now this memory block belongs to my program. So this is how the malloc works. Now, the thing is that malloc may occur a memory leak, which means that after your program has used this memory block, but you forgot to free it, what will happen is that this memory block will be always there, or it will grow and will cause a memory leak. So to avoid that, we use a free function, free. What it does is that it removes the pointer which was pointing between my program and the memory block. It will remove that. The data will still reside in this memory block, but now let's just say, let me say that after we have malloc, the program is now pointing to this memory block. So it is occupied, so it will be get removed from the table. But once I free it, the uh, once I free it, the program will lose its ownership, and now table will once again point to that uh, block. So yeah, like that. So now again, this block is free. So that's what free function do. Now the thing is that will your data will also get lost? So no, your data will still reside it in here. Uh, let's say that my program store uh, integer 575678 in this memory block, and but still you can see that this my program have lost the ownership to this memory block, but still the data reside in it. The thing is that once another program comes access this block, then it can overwrite and change its data. But the main thing is that hey, this block is freely available, and you can also make an array using it. Like the malloc can give you, uh, the malloc can give you the first element pointer like this. You can access this pointer, and then you can define. Let me just. Okay, okay, it is not moving. So leave it. So what we can do is that now. this block can further point to this block. So like that you can have an array. So that's it. But remember that once your program loses the ownership of this memory block, but still the array type will reside. Let's say that this was 5, 6, 7, 8, and this was 1, 2, 3, 4. So yeah, the data will still reside until and unless another program comes in and overwrites it. Now let's jump into the terminal. Uh, what I will do here is solve an operating system CGPSS questions. So I already have the file. Let me open it. Uh, nano null.c. So the first thing they told us to create a null.c file which creates a pointer to an integer. That means that this void type pointer returning should be integer, casted as an integer. That's what we are doing it here. And then they are just telling us to point that value of this pointer to a null. And we will be using Valgrind to see what actually happens here. So let me just, I guess I have already compiled it. Yep. So I will just do null. So this is what Valgrind gave me. So we will see it. The number you are seeing here is nothing but process ID of this program that I ran. And so here are the output of my file. The malloc memory address is this block. And now my pointer is pointing to this with a value of 0. And you can see here that definitely lost. Leak summary. So since we have lost 4 bytes in a one block, that means that hey, I have a block of one malloc of 4 bytes. This means an integer size, and I have lost it. Why? Because I haven't freed it. So you have to free that, or else it will get uh, memory leak. So, and here total heap usage, there were two allocations, two alloc, one, why two? We did only one because one was from the printf function we used and another one was our malloc. And the printf freed its memory block as a good person, but we didn't and we got a leak summary. So how to solve that? Let's open the file again and let's jump to this and free the pointer, that pointer. Let me save that. And I have to compile that. Null.c o null. And let's just ignore this warning for a moment because some casting error there is. And let's just run the program again. You can see that process ID has been changed. And now you can see that hey, there are no memory leak summary. So that means there is no memory leak in my all heap blocks were freed. No leaks are possible. So because why? Because I freed that memory. What I did is that earlier it was my program was pointing to a memory block and I forgot to remove it. So yeah, my program got exited, so does this pointer, but this memory was just lost. But once I freed the memory, this pointer can be removed easily, added here, and hey, now this block is usable, reusable. So that's the thing with the malloc and free. Thank you.